Hello, my math proteges. So today is lesson 4 of transformations, and really lesson 4 is all of get on lesson 1, lesson 2, and lesson 3 together. So we're going to be looking at essentially all of the transformations at the same time. So we're going to stretch an object and reflect an object and translate an object all in one. Okay. We have kind of alluded to the fact that there's an order that has to be done with that. When we dealt with reflections at the end of the reflections lesson, we threw together reflections and translations at the same time. And one of the things I talked about there was that the reflection had to be done before the translation. And my reasoning behind that, if you remember, was because a reflection is essentially multiplying the x or the y value by a -1. And according to BEDMAS, you would have to handle a multiplication before you handle the addition and subtraction that would be any sort of a translation, okay? Stretches, we talked about yesterday, that's also a multiplicative factor, okay? So stretches also have to be accomplished before the translations. The translations are the last thing we deal with. Now, by convention, we deal with stretches before we deal with reflections. So when you're doing these things, either when you're describing the transformations, we will always start by describing the stretches that we see, and then the reflections that we see, and then the translations that we see. When we actually go to do it, if you're given a picture and you're asked, okay, perform all these transformations on it, we will also go in that order, but it'll be a little easier because what we're going to do first is set up a mapping rule, set up the image point, and then all we need to do is take the original coordinates, kind of plug them into what our mapping rule states, and that's going to give us what that new coordinate would be. Plot the new coordinates and then reconnect the dots. Okay, so drawing them is actually fairly easy once you've established what your mapping rule would be. Okay, so in general, okay, sorry, I missed the top there. We have now seen all possible transformations that can be applied to a function. In general, all functions we work with can be written like this. Now, if I had a choice between the green and the purple, really, I think it's easier to go with the purple graph, or the purple equation, sorry. Before you start describing transformations, always have it as y equals, okay? It's just a really good habit to get into, and it will help you a lot as you go through this. So we have an a parameter, we have a b parameter, we have an h parameter, and we have a k parameter. We're gonna go through each one of those. A reminder though, that there are 6 items, okay? There are 2 reflections, there are 2 translations, there are 2 stretches. Actually, there are 3 reflections, but we won't talk about the diagonal one just right now. So 6 items, 4 parameters. You have to realize that that a value is actually telling you 2 different things. The a value is going to tell you whether you have a vertical reflection there, and the a value is going to tell you whether you have a vertical stretch there. Okay, same with the b. The b value will tell you the horizontal reflection as well as the horizontal stretch. They are 2 separate items. Okay, so if a was -3, don't ever tell me that that's a stretch of -3. Okay, it's not a stretch of -3, it's a stretch of 3 combined with a vertical reflection. Okay, but you have to keep them separate. Stretches are not negative, stretches themselves are always positive. So let's just unpack that and we'll go through each parameter here. So that's why you'll notice here I said the absolute value of a when I'm talking about stretches. That's just us communicating that we don't care right now whether it's positive or negative. We're just really looking at what number that a value is. So the absolute value of a is the vertical stretch by a factor of a. Remember, when we have it written in that form where y is all by itself, we can just read a exactly as it is, okay? And that would be about the x-axis. This means that we multiply all of our y values by the value of whatever the absolute value of a is. The absolute value of b is the horizontal stretch by a factor of, now you got to watch this one. This was the one that we had to interpret a little bit, remember. The stretch factor is always the reciprocal of the b value. So it'll be a stretch factor of 1 over b about the y-axis. This means that we multiply all the x values by the value of whatever that absolute value of 1 over b is. Okay, Then when we go to reflections, this is where we deal with that negative number. So if A is less than 0, we're essentially saying if A is negative, then we have a vertical reflection about the x-axis. A reminder, always keep that visual in your head. If I'm going about the x-axis, I'm flipping, okay? I'm flipping down like that. So that's where the vertical reflection comes from. This means we multiply all our y values by -1. Or you could also look at that as y gets replaced with -y. Okay, we've kind of used that terminology as we've gone through things as well. If b is less than 0, so if b is negative, that's going to give us a horizontal reflection. And that would be about the y-axis, right? If I flip horizontally, I'm flipping against that vertical line that you see there, which is the y-axis. This means we multiply all the x values by -1, or the other way to look at that would be we replace x with -x. Now, that is told to us by A and B. We have also talked about a diagonal reflection. That's when x and y are switched. So when x and y are switched, we have a diagonal reflection, and that's about the line y equals x. Okay, so let's talk about translations now. If h and k is what we're talking about here, h is the horizontal translation, and then we're going to go h units left or right. If h is negative, we're going to the left, and if h is positive, we're going to the right. Okay. Just be careful with what I just said. Let's say h is -3. If h is -3, remember that in my equation, it's x minus whatever h is. So in your equation, you would have f of x minus, now I said h was -3, so x minus -3. That would get simplified in this equation to x plus 3. So when you see x plus 3, you need to remember that that means my h value there is -3, and that's what's sending me to the left. When the h value is positive, I'm heading to the right. K is the vertical translation, and then again, if k is positive, I'm going up, and if k is negative, I'm going down. Okay? Okay, invariant points. Remember that invariant points are points that remain unaltered in a transformation. Okay, they are not necessarily intersection points of the two graphs. They will be intersection points of the two graphs, but not all intersection points are invariant points. Sometimes intersection points are just that the new graph ended up in some spot where the old graph happened to be, but the point still changed. Okay, so an invariant point is a point that never moves after our transformation. Invariant points always occur on the line that we are stretching or reflecting about. So invariant points for horizontal stretches or reflections will be on the y-axis. The invariant points for the vertical stretches or reflections will be on the x-axis. So like we'd be looking for the intercepts there. That's why I put those in brackets. And invariant points for diagonal reflections, well, what line are we reflecting on? That's the line y equals x. Okay. All right, so image points. Image points are an easy way to map where any point will end up on our function. So xy maps to x plus 2 negative y. That tells us that we're going to take every point in the original, add 2 to the x value, and we're going to switch the sign of the y value. Okay, and that will be our new point after the transformation. So there's no trick to this. When I see x plus 2, I know I'm heading to the right 2 units. When I see negative y, I know I'm flipping my y, so that's a vertical reflection. Okay, as we see it, that's what we do to the points, and that's how we describe the transformations. So there's no trick to an image point. It tells us exactly how the transformation will occur. Okay, always perform transformations in the order SRT. That was the conversation that I was having at the beginning of this lesson. S for stretches, R for reflections, and T for translations. Inside stretches, we would state the horizontal item before the vertical item. Okay, so say we had all 6 things happening here. When we list them, when we describe the transformations, we would go, I have a horizontal stretch of something. I have a vertical stretch of something. I have a horizontal reflection of something. I have a vertical reflection of something. I have a horizontal translation of something. I have a vertical translation of something. Okay, now if you don't have those, you don't list them. I'm just saying that's kind of the order that you would follow down. The most common mistakes First of all would be forgetting to factor the function. Remember that inside my f of, that has to be in a bracket within a bracket there before you can read the transformations. So if you're looking at this f of 2x plus 6, you need to immediately see there, no. Okay, so let's talk about that for a second. It doesn't actually affect my horizontal stretch. My horizontal stretch is going to be 1/2. So you're going to get that right, but you're not going to get the horizontal translation right, because right now you're going to tell me, oh, I'm translating 6 units to the left, but you're not, because that 2 hasn't been factored out yet. You have to factor that 2 out, and that's going to be x plus 3. So now really what happens is the horizontal translation is 3 units to the right. 3 units to the left. Okay, so super important that you remember to factor the function. Also remember that the horizontal stretch is the reciprocal. The horizontal translation inside that transformation equation is always the opposite direction of the sign, and that's because inside the equation, it's x minus whatever the h value is. Always keep the transformations separated, okay? So this transformation is now separated from this transformation. In other words, keep your function factored, okay? All right, so this is not in your book. Again, it's just me having a quick conversation with you. I wanna make sure, because we've thrown these sort of phrases and words out to you, I just wanna make sure you understand everything. So function notation, an image point, and a description in words. So every one that I've written here involved the same set of transformations. And I just want you to see how it's all going to look different depending on how you're being asked to answer. So the description in words, we can follow that from the green graph or the orange, sorry, the green function or the orange function. And you're just listing them as I stated, and notice that I'm writing them in the right order. So I started with my horizontal stretch of 1/3. I could have gotten the b value here and remembered that is the reciprocal, or I could have looked at my image point and remembered that those are read exactly as is. The vertical stretch of 2, I could have gotten from my a value here, or I could have gotten it from my image point and remembered that that's read exactly as is. Horizontal translation 1 unit right. Again, I see that here and I see that here. And a vertical translation 2 units up. I see that here and I see that here. Okay, you need to be comfortable going from function notation to a description, image point to a description, description to function notation, description to image point, image point to function notation, or image point to description in words, okay? Any sort of connection between those two, you have to be very, very comfortable flowing in between, okay? So that's why I wanted to kind of pick one and show you all 3 at the same time so that you could kind of think about, okay, how would I go from there to there, or from there to there, or whatever, okay? All right, so I'm back in your book. Describe how the graph of each of the following transformations can be obtained from the graph of y equals f of x. So we're just describing the set of transformations here. You want to make sure you have y equals first, and you want to make sure you're in fully factored form. For this guy, I am in fully factored form, so that's good. But I've got this -1. Let's bring that over, and it'll be +1 on the other side. So I have y equals f of -2 bracket x minus 3 plus 1. 1, 2, 3, 4 statements you're going to make for me. This is a good time to pause me and try them on your own. So you should have told me that you have a horizontal stretch of 1/2. That's coming from this 2. And that's about the y-axis. The horizontal reflection, that's coming from here, also about the y-axis. A horizontal translation 3 units right would be my h value of 3 here, and a vertical translation 1 unit up. Okay, let's try the next guy. Now, a couple things you need to see here before we start describing the transformations. Number 1, I want you to see right away that we're not in fully factored form, so you're going to have to factor the 4 out of there. Number 2, most of you are going to feel comfortable to say, hey, I got to bring that 3 over here, and that would become -3 on this side. Okay, but now look at what's left. You're left with this negative on the y, which means you have to divide everything by -1. Now, everything means every term. This whole thing here is one term. So that whole thing gets divided by -1, which would divide out the negative signs there. Okay? Where a lot of kids go wrong is they forget that this -3 is a separate term. So that guy also has to be divided by -1. Every term has to get multiplied by -1. So those negatives divide each other out. And so I'm going to be left with +3 there. So my cleaned up simplified version here is actually going to be y equals 5, f of 4 bracket x minus 2, and then we're going to go +3 at the end. So now, 1, 2, 3, 4 statements you're going to make for this guy as well. Pause me and write them down. And the statements that you've made are horizontal stretch of 1/4 about the y-axis, a vertical stretch of 5 about the x-axis, and then 2 to the right, horizontal translation 2 units right, and vertical translation 3 units up. All right, good. The point A, which is 6, 5, is on the graph of y equals f of x. The point A is mapped onto the point A prime, which is -2, 19. So we're saying the point 6, 5 maps to the point -2, 19. Okay? And that's for the function y equals a f of -2 bracket x minus h plus 4. And we are told, okay, we have to find the values of a and h. Okay? Well, what happens is we have to think, okay, what have I done to a? Or, sorry, a involves the y. So what have I done to the y? So I'm going to have to take 5. I'm going to have to multiply it by my stretch, which is a, and I'm going to have to add 4 to it. Okay, so that just becomes a cute little equation. I'm just going to write it down up here for you first because I don't remember which one comes first on my slide. So what I just said is I'm going to have to take 5, I'm going to have to multiply it by a, and I'm going to have to add 4 to it. And when I do that, I need to get out what my new y value is. Well, my new y value is 19. So now I just solve for that. 5a equals 15, a equals 3. Okay? Then I'm going to do the same thing with the x. I know I start with 6 and I have to end up with -2. Well, how do I do that? I'm going to take 6. I'm going to multiply it by -1/2. Okay, because my stretch factor would be the reciprocal of the 2, and then the negative tells me I need to reflect it. And then I'm going to add h to it because I'm moving h units. And when I do all that, I would end up with -2. So now I need to solve for that. Well, 6 times -1/2 is -3 plus h equals -2. Add 3 to both sides, so h is going to equal 1. Okay? So I'll put that up on the slide for you. I established my mapping rule, and then I figured out what a and h were. And I'm glad I wrote it on the board first because I had my slide in the other order. So everything worked. I'll give you a second though, just to make sure you're okay. Really, I just wanted a drink of coffee. Okay, we'll keep going. The function 2 times g of x equals f of 3 bracket x minus 5 is a transformation of y equals f of x. If the point p prime, so that's the new point, 14, 12, is on the transformed function, determine the original point, which would be the coordinates of p. Okay, so actually, similar question, it's just that we're given different information and asked to solve for different things, but you set it up the exact same way. You're going to think about a mapping rule. This one, you know the whole mapping rule, so you know that I am going to have to take the original point. Let's move this 2 over here first, right? And that's going to be 1/2. So now I'm going to take the x value of the original point. I'd have to multiply it by 1/3, and then I'd have to add 5, and that's going to end up with 14. Well, what I just said there was actually just a little algebraic equation to solve, right? I just said I'm going to have to take my x value. I'm going to have to multiply it by 1/3. I'm going to have to add 5, and then I have to end up at 14. Well, let's solve that then. That's x over 3, x times 1/3, I'm going to subtract 5 from both sides, so that's 9. So x has to equal 27. Okay? Then I'm going to do the same thing for y. I'm going to have to take my original y value. I'm going to have to multiply it by 1/2 because that's my a value. I'm going to have to, that's all I'm going to have to do. There's no vertical translation there, right? So when I do that, I need to end up at 12. So y has to be 24. So my original point on the original graph would be 27, 24. Okay, so make sure you conclude the coordinates of P are 27, 24. Okay, excellent. This is so much fun. Okay, the graph of y equals f of x undergoes transformations to produce the graph of 2 bracket y minus 1 equals negative f bracket x plus 2. Determine the mapping rule. So the mapping rule is the same as the general form of the image point. They mean the same thing, okay? So I want to get this to say y equals first, and then I'll try and read the mapping rule from there. I'm going to divide both sides by a half. Sorry, divide both sides by 2. And that's going to end up with a half on this side is what I was thinking out loud on. But then that leaves me with a y minus 1 here, so I'll also have to add 1 to both sides. So when I clean up that equation, I get y equals negative 1/2 f of x plus 2 plus 1. So now the mapping rule, what's happening to x? Well, actually, all that's happening to x is I'm moving 2 to the left. So that's going to be x minus 2 in my mapping rule. And then what's happening to y? I'm going to have to multiply it by negative 1/2. That will deal with the stretch and with the reflection. And then I'm going to have to add 1 to it. So my mapping rule is xy maps to x minus 2, negative 1/2 y plus 1. Hey everyone, future me just fixing an error from past me. The graph of y equals f of x is transformed to become the graph of g of x. Determine the equation of the transformed function. Okay, so how am I going to handle this? Well, the first thing I want to do, think mathematically here. When we deal with transformations, we have to deal with the stretches and we have to deal with the reflections first. The reason we have to do that is those are multiplicative factors, right? And by order of bed mass, you deal with the multiplication aspects of things before you deal with the addition aspects of things. So what I want to do is I want to take a look at these guys and I want to establish, okay, what's going on for my stretches? What's going on for my reflections? And then after I've got those established, I'll deal with the translations, okay? So let's talk stretches first. In order to talk stretches, what I want to do for the horizontal stretch, I need to compare the widths. So f of x goes from -4 to -1. So it's 3 wide. G of x goes from 2 to 8. Okay, so it's 6 wide. Okay, so if my shape has gone from something that is 3 wide to something that is 6 wide, that's a horizontal stretch of 2. Okay. All right, then I'm going to compare the heights, and that'll help me with the vertical stretch. So f of x goes from a height of -2 to 2, so that's a height of 4. And then g of x, I'm going from 1 to 3, so that's a height of 2. So that gives me so I have a horizontal stretch of 2, and I have a vertical stretch of 1/2. Okay, now I know I have yelled at you in other places, never ever write HS and write BS, okay? And I'm still gonna yell at you about that. You should never do that, okay? If it is an answer that you're giving. Here, this is just me thinking out loud, okay? So when you're thinking out loud, it's okay to write abbreviations. It's when you are actually talking to the reader about a horizontal stretch, then you'd have to use the word horizontal stretch or the phrase horizontal stretch, okay? All right, now I want to think about reflections. Now, I'm pretty confident that a vertical reflection has not occurred here. And the reason I'm pretty confident on that is because of the orientation of the graph. F of x points up like that, and g of x still points up like that, right? If there was going to be a vertical reflection, one of them would have had to have pointed down. Okay, so I know there's no vertical reflection. To deal with a horizontal reflection, I need to think through, let's just go from, let me see if I can take off the ink for a sec. Let's go from here to here for a sec, okay? Well, that goes 2 wide and 1, 2 down to go from that point to that point, right? Think about this now. If I applied the stretch to that, I have a horizontal stretch of 4. Sorry, I have a horizontal stretch of 2, which means my 2 wide should now be 4 wide. And I have a vertical stretch of 1/2. Okay, so I need you to think through my logic here. That means that from this point to this point, instead of going over 2, I'm going to have to go over 4. And instead of going down 2, I'm going to have to go down 1. That would apply the stretches, because remember, stretches go before reflections, right? Okay, so I'm looking for which 2 points are now connected by a horizontal aspect of 4 and a vertical aspect of 1. Okay, do you follow what I did there? I took the 2 that was the horizontal and applied my horizontal stretch. And I took the 2 that was the vertical and applied my vertical stretch. Here's the point I'm trying to make. If I looked at this, this is still going 1, 2, 1, 2. The stretches aren't applied there. Take a look at the other end. Here's my 1, 2, 3, 4, and here's my 1. So this arm has now turned into this arm, which means there actually has been a horizontal reflection here, okay? There has in fact been a horizontal reflection. So I'm going to write all this stuff down over here. I'm going to say, okay, I've got a horizontal stretch of 2, I've got a vertical stretch of 1/2, and I have that horizontal reflection that we just figured out, okay? Now what I do is I pick a point and I want to see if all I did was this, where would that point go? Okay, so I'm going to pick the point -3, 1, because I'm really, really confident that that -3, 1 is going to turn into 6, 3, right? If I just applied those 3 items to the point -3, 2, sorry, I think earlier I might have said -3, 1. That's -3, 2. You probably already caught me on that, but okay. If I just applied this, the horizontal stretch of 2 and the horizontal reflection, well, that would turn into 6, right? Because I had essentially multiplied -3 by -2. And then the vertical stretch of 1/2, the 2 would turn into 1, okay? And so now that puts me at 6, 1. Okay, but that's not where I want to be. I want to be at 6, 3, so I have to add in my translations. I have to slide the rest of the way there, essentially. Which means I'm going to have to add in, I need to go up 2, okay? All right, so I see that -3, 2 mapped to 6, 1, and then I know I need to go up 2. So my final result is going to be, this is the transformation equation. This describes the transformations, okay? So g of x equals 1/2 f of -1/2 x plus 2. I've shown my horizontal stretch of 2, I've shown my horizontal reflection, I've shown my vertical stretch of 1/2, and I've shown that I can go up by 2, okay? All right, now, you should be able to, if you've done this right, it should work for all of the points. So if you want to check one of the other 2 points, so if I took this point here, which is at -4, -2, I'm pretty confident that that's going to end up at this point here, which is 8, 1. So let's test that with these transformations. So -4, if I multiplied that by the -2, that would give me the +8 that I want. For -2, if I multiply that by 1/2, that's going to give me -1. And then if I move -1 up 2, I'm right at the 1 that I want. So in fact, -4, -2 does map to 8, 1. Okay, so everything works. All right, I'll take you back to past me now. All right, what transformation of the function f of x equals x cubed to g of x are described by this mapping notation? State the equation of g of x in terms of x. Okay, so the first thing they asked is for the description of the transformation. So you're going to look at that mapping rule and you're going to write out the description. You're going to pause me to do that, and you should have 1, 2, 3, 4 different statements. Your 4 statements are You've got a horizontal stretch of a third about the y-axis. Remember that in mapping rule, you read them exactly as you see them. Vertical stretch of 2 about the x-axis, horizontal translation 2 units left, vertical translation 4 units up. Be very specific in how you are communicating this to me. I need to see all those words. Every one is important, okay? So be super, super specific. Now, it asks you for g of x in terms of x. That's the actual graphable equation, okay? To do that, though, the easiest thing to do is to come up with the transformation equation first. So I want you down here to tell me what the transformation equation is. So horizontal stretch of 1/3, that's going to be a b value of 3. Vertical stretch of 2, that's going to be an a value of 2. Horizontal translation 2 units to the left, x is going to be replaced with x plus 2. Vertical translation 4 units up, k is going to be 4. So you should be looking at this for your transformation equation. Okay, now let's unpack this. Here is f of x. F of x is x cubed. So this says take x cubed, multiply it by 2, and add 4. And then, hey, while you're at it, replace the x that you see with 3x plus 6. Okay, I'm going to distribute that to do the replacement because I'm not looking at it from a transformational perspective anymore. Okay, so here I go. I took my x cubed. Okay, I multiplied it by 2 and I added 4. Now I replaced my x with 3x plus 6. So now I have some math to do. 3x plus 6 all cubed. Well, that's 3x plus 6 squared times another 3x plus 6. We can do that in our head. 3x plus 6 squared, square the first, double the products, square the last. So you'd be looking at 9x squared plus 36x plus 36. Okay. So I've got 3x plus 6 times 9x squared plus 36x plus 36. This is a good time to pause me and keep going. If you haven't paused me, it'd be really good for you to try this first. Everything's easy when you watch me do it. It's a little different when you're doing it on your own. Okay, so now we multiply the 3x by all those terms and the 6 by all those terms. Then we're going to clean up the middle. So my 108x squared and my 54x squared can come together. My 108x and my 216x can come together. Now that that's simplified, I'm going to multiply everything by 2, and then I'm going to add the 4 into the constant term that I see there as well. Okay, so final answer is g of x equals 54x cubed plus 324x squared plus 648x plus 436. Now, what is that? That is the graphable equation that I could stick in as like y2 and have x cubed be y1. And my y2 picture would look exactly like my y1 picture after all these transformations have been applied to it. Okay, so this is g of x in terms of x. All right, awesome. So this is where you're heading. Now there is a lot of practice to do with combinations. Take your time and be really, really neat, tidy, and specific with your communication. Okay, remember math is a language. So part of our job in 30-1 is to really force you to communicate that language properly. Yeah, so next lesson we're going to talk about inverses. So I'll see you there. But in the meantime, go through this and come see me if you have any questions. Okay, take care, guys.